Okay, good evening, ladies and gentlemen. This is Math with Kieno, and today we're going to do fractions. If you don't know what a fraction is, this is a fraction. Let's see, 1 over 2. So it's like a whole number divided by a line and then another whole number. And we need to look at this a certain way. We could look at this as a part of a whole. Let's say we had a piece of pie and 1/2 represented a certain piece of pie. So the whole is 2 parts. So we have 2 parts here, and this 1/2 actually represents half of that part. We could also call this is over of. This is 1 of 2. Let's look at another one. 2/4. Okay. 2/4. This is the part, and this is the whole. Now we have 4 parts, but we're going to use up 2. So this will represent 2/4. So 2 of 4. Now we have special names. This is a numerator. And this is a denominator. Okay, so the top part is the numerator, the bottom part is the denominator. Okay, so a lot of people have trouble with fractions, and the only way you're going to get good at fractions is by doing them again and again and again. We get good at things by repetition, and just by doing them over and over again. So just to jump in, let's look at the old-fashioned way we should do fractions. Take like 1/2 and 1/4. So we want to know what is 1/2 minus 1/4. Okay. So what we would do is we would look at the 2 denominators and we would look for the lowest common denominator. And basically what we would do is we would convert this into fourths, because this is halves, this is fourths. So we want to convert this to fourths, and to convert this to fourths, we basically have to multiply this by 2 to get 4, and whatever we do to the bottom, we have to do to the top to make it even. So this would be 2/4. 1 times 2 is 2, 2 times 2 is 4, and we leave this alone because we've converted this fraction into fourths. This is 2/4. This is 1/4, and this is the only way it could work. It's like converting money to someone else's, like dollars into euros or whatever. So we're converting halves into fourths, and this is actually equal to 1/2. Okay, 1/2 is just a reduced version of 2/4, and then after that, 2/4 minus 1/4 is 1/4. And that would be our final answer. Another way we could look at this, and I like to call it my rapid math method, is, and I did not create this. I'm not taking credit like, oh, I created this. I did not create this. I've worked with numbers and a lot of people. In pretty much all industries I've ever worked in, I've always worked with numbers. And I always had to be a mathematician. But watch this. Now we know our answer is 1/4 based on what we calculated earlier, but something really interesting happens. If we take 4 times 1, which is 4, keep in mind we have this minus sign there, and then 2 times 1, which is 2, and then we take the bottom and we multiply 2 times 4, we could say 4 minus 2 is 2, and 2 times 4 is 8. Now, this is not it's not reduced all the way. We have 2 even numbers which can be divided by 2. And our final answer, 2 divided by 2 is 1. 8 divided by 2 is 4. So you can see how we arrive back at the number we calculated doing the old-fashioned way. Okay. Let's try another one. 1 over 4 plus 2 thirds. 3 times 1 is 3, keeping the addition sign. 4 times 2 is 8. And then 4 times 3 is 12 plus 1, 11 twelfths is the answer. It cannot be reduced any further. In a typical way, and normally in some cases, if we have an odd number and an even number, or odd number, even number, it probably cannot be reduced, but the number's pretty low. And there's really not anything, we couldn't divide the top and the bottom by 2 to get a resultant. And we can divide it by 3, so that's a good indication. I'm not saying that's the end all be all, but if I can't divide the top and bottom by 2 and get whole numbers in the numerator and the denominator, if I divide it by this by 2, it'd be 5.5. 5.5 can't be a numerator. If I divided this by 3, it would be 3 remainder something, but it'd be a decimal or a fraction. So we can't have a fraction just in here. There's a whole number at the top, a whole number at the bottom. And traditionally, the numerator in a proper fraction, not improper, but in a proper fraction, the numerator is smaller than the denominator. So we can't do anything else with this. 11 twelfths is the final answer. 2 thirds plus 1/5. Again, 5 times 2 is 10. 3 times 1 is 3. We'll keep the addition symbol in play. And we just multiply the bottom. 3 and 10 is 13 over 3 times 5, which is 15. And we have 2 odd numbers, but again, if I try to divide the top and the bottom by 3, this would give me 5, but this would give me a weird number, because this can go into 3 can be divided into 13 about 4 times actually, but there'd be something left over, because this 3 times 4 would only give us 12, and it's just not good enough. So we can't reduce this anymore. 13/15 is our final answer. A cool thing that happens when the numerator in an addition of fractions, when the numerator is both 1, we can look at this as 4 plus 3 over 4 times 3. And then 4 plus 3 is 7 over 12. That's the final answer. Whenever you see a 1 in the numerator in both, and we're adding, and there's a numerator of 1 only, doesn't work with anything else that I know of. But when you see 1 4th plus 1/3, just think of it as 4 plus 3 over 4 times 3, and do the proper addition and multiplication on the bottom, and then that gives you your final answer. Okay, let's say it was 1/4 plus 1/5. Look at it as 4 plus 5 over 4 times 5, 9/20. Okay, I was trying to look for another one, but we'll just press on because I want to stay with my method. 3 over 4 plus 1 over 5. 5 times 3 is 15. 4 times 1 is 4. We'll multiply the denominators. We'll get 20 for our denominator, and 15 plus 4 is 19 over 20. It cannot be reduced anymore. 1/4 plus 3/5. 5 times 1 is 5. 4 times 3 is 12. And then 4 times 5, 20. 5 plus 12 is 17. 17 over 20. Can't be reduced anymore. One half minus 1/3. We can't do, it's not an addition problem, so we can't do our little quick and easy method. So 3 times 1 is 3, minus 2 times 1 is 2. Multiply the denominators. 3 minus 2 is 1. 2 times 3 is 6. That is the final answer, and it can't be reduced anymore. 2/3 minus 1/4. 4 times 2 is 8, minus 3 times 1 equals 3. Denominator 3 times 4, 12. 8 minus 3, 5/12. Can't do anything else with it. It's reduced. Three fourths minus 1/7. 7 times 3 is 21, minus 4 times 1, which is 4. And then 4 times 7, our denominator is 28. 21 minus 4, 17. Can't be reduced anymore. That's our final answer. 2/3 minus 2/7. 7 times 2 is 14, minus 3 times 2. So we're cross multiplying each time. 6, and the denominators are multiplied. 21, 14 minus 6, 8/21. That is our final answer. Four over 8 plus 1/4. 4 times 4 is 16. 8 times 1 is 8. And then we'll multiply the denominators. We get 32 in the bottom. 16 plus 8 is 24. These are big numbers, and they can be reduced. If we divide and they're even by 2, we'll get 12/16. It can be reduced even further, 12/16. If we divide the top by 2, divide the bottom, because whatever we do on the top, we have to do on the bottom. When we're reducing a fraction, when we look at the numerator and the denominator, whatever's done to the top has to be done on the bottom. When we're reducing it, we get 6/8. Can be broken down again. 3/4. And 3/4 is our final answer. And again, if you gotta go back, you can rewind, go back to the beginning of this video. If you don't get it, but just do it again and again and again, and I promise you, by repetition, you will learn the method, and it will come to you. 9 times 1 is 9, plus 3 times 3 is 9. Multiply the bottoms, 27, 18. This can be reduced. If we divide the top by 3, bottom by 3, we get 6/9. Again, by 3, 2/3 is our final answer. Okay, I'm trying to find something interesting. 2/3 minus 1/2. 2 times 2 is 4, minus 3 times 1 is 3. Multiply the denominators. 6. 1/6. 1/6 is our final answer. Let's get something real. 3/5 minus 1/3. 3 times 3, 9. 5 times 1, 5. Keeping the minus symbol. Multiplying the denominators. 15, 9 minus 5 is 4. 4/15 is the final answer. Let's see, this is interesting. 3/6 plus 2/12. 2 times 3 is 36, plus 6 times 2 is 12. 6 times 12, is 72. 36 plus 12 is 48. These are two big even numbers, so we can break this down even further. 48 over 72. We divide the top by 2, and we're reducing. Whatever's done to the top is done to the bottom. We get 24 over 36. Divide by 2 again. Top and bottom, we get 12 over 18. We can keep going. We get 6 over 9, and then we can divide by 3, and we get 2/3. So we keep breaking it down. We start with 48 over 72, divided by 2, got 24 over 36. We divided by 2 again, the numerator and the denominator. 12 over 18, we divided by 2, 6 over 9. And you might look at that like, nah, it can go further if we divide the top and the bottom by 3. And we've broken this all the way down to 2/3. Let's see, I'm looking for something interesting. So if we had 4 over 14 and 2 over 14, we don't have to convert anything really because the denominators are the same. So this would be 6 over 14. Can that be reduced? It sure can. We divide the top by 2, divide the bottom by 2. We come up with 3 over 7. Okay. 1/3 plus 3 over 9. 9 times 1 is 9. 3 times 3 is 9. Then 3 multiply the denominators. 27. 18 over 27. Can that be reduced? Yes, it can. If we divide it by 3, we get 6 over 9. We divide by 3 again, the top and the bottom, we would get 2 over 3. Because 2 times 3 is 6, and 3 times 3 is 9. So our final answer is 2/3 to this question, 1/3 plus 3/9. Now, if something weird happens, like in this next question, let's say they gave us 4/12 minus 1/3. You go, wow, okay. You apply the method. You say 3 times 4 is 12, minus 12 times 1 is 12, and then we multiply the denominators, and we get 36 in the denominator and 0. Because 12 minus 12 is 0. This can be, that's the only solution. Because another way to look at the fraction is, well, I won't even go into that aspect of it. But the numerator cannot be 0 because, again, we said the numerator is the part, the denominator is the whole. Okay, so you can't have 0 parts of anything. It just doesn't work. All right. So you would have to talk to your teacher, see whether they like just a 0 put up or something called no solution. But 0 can never be in the numerator because we're trying to define, like in our pi with 1/2, we're trying to define what part of the whole does this represent. When we look at 1/2, what part of 1 is of this 2 pieces? So if the 0 is there, then we're not really defining anything. Now the next thing I get a lot of emails about are whole numbers. Whole numbers, not whole numbers, mixed numbers. Okay, let's say we take something like 1. Here is we have a whole number and we have a fraction. Now let's just think about this on a number line. Say this is 0, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. If we think of this in terms of measurement, 1.5, we wind up right here. This is where we wind up in between 1 and 2, 1.5. That's what that represents in measurement of something. Okay. We have a whole number and a fraction. Now, when we take this number, we can also take this and turn it into a improper fraction. But the way we do that is we have to think of this as, and I'm going to use a different color. I'm going to put a times symbol there and a plus symbol here. And what we do is we work it from, let's say, whole number is the outside, which is the 1. Numerator. And then denominator. I'm just going to put denom for short. So how we find our mixed number, which in this case will be 3 over 2, the 2 is always going to stay in the bottom of our resultant answer, right? We're always going to wind up with 2. But what we do is we go from the denominator to the whole number, multiplying, and from the whole number we'll add plus symbol. So 2 times 1 is 2, plus 1 is 3. So that's how we get our numerator when we're converting it to an improper fraction. So 2 times 1 is 2, add the 1 on the top of the fraction, and we get 3. And 3 over 2 is the whole number, improper fraction. So 1 and 1/2 is equal to 3 over 2. All right. So let's take 1 and 10 over 21 plus 4 and 5 over 7. Now what we could do is we could take these numbers and convert them into improper fractions. We can use our rapid math technique. But I'm going to elect not to. I'm going to do this the old-fashioned way because it's a lot easier. And I'll show you why. I'm going to show you how ugly this can get. Now sometimes you gotta kind of be able to switch when you're working math problems. You have to do what's easier and what's best for you. But if I converted this to these two into improper fractions and I worked them the rapid math way, it would go like this. 21 times 1 is 21 plus 10 is 31. The numerator stays here, so it will be 31 over 21 plus 7 times 4 is 28. Add 5, 33. 33 over 7. Now, these are the same, in parentheses, the same thing. Same numbers. These are just converted into improper fractions. Now, the reason why I say this could get ugly is because what we would have to do is we'd say 7 times 31. We have to multiply 7 times 31 and add that to 21 times 33. And we'd have to divide that whole total thing by 21 times 7. Now, I could work this and I could sit here and I could be like, okay, 31 times 7, 217. Alright, so this is 217. And then I take our next number, 33 times 21. 1 times 1 is 3, 1 times 1 is 3. Drop down a level, 2 times 3 is 6. 2 times 3 is another 6. 693 would be our answer. And we've just multiplied this, 693. And we found that answer. Then we got to find out 21 times 7. So 21 times 7. Alright, you can see that it's 147. 7 times 1 is 7. 7 times 2 is 14. 147. So the answer here is 147. Alright. Then, after we do that, and it's all because we're the mixed number, translating it to the improper fraction. So then our next thing that we would have to do is we'd have to add this. 217 plus 693. 10, 11, 9. So it'd be 910. So we take 910, which is this, and we'd have to divide 910. We divide that by 147. Now, for me, I could do it. If you hate fractions and you're not very good at fractions, this could be a bear for you. But what we would do is we would have to actually wind up dividing this. And this actually would be 910 over 147. That's how it would look as a fraction. That's what we would wind up with. So we have to see how many times 147 could go into 910. We come over here, we say 147 could go into 910, say about 7 times. Right? Or that's not, let's back up a little bit. This actually would have to be reduced. So if we divided the top by 7 and divided the bottom by 7, that you really wouldn't even know how to do that. To come up with this number, you'd have to play with it. It's odd numbers, or odd and even. So 2 doesn't work, 3 doesn't work, 5 doesn't work, because if we tried to divide this, then, you know, so. But basically, we would keep playing, using up a lot of time, then to come to the conclusion that both the numerator and the denominator could be divided by 7, and then it would basically break our fraction down to 130 over 21. Alright, and you can pause this and check it yourself, but it works. And then after that, we would have to convert this to, because this is an improper fraction, back to a mixed number, and we come up with 6 over 4 over 21. Okay, so that is a lot. Only because now we got these big giant numbers to work with. So what I would recommend, if you saw this question like this, I would recommend that you do it the old-fashioned way. You know, if you just had regular fractions, no whole numbers outside them, then I would work them the rapid way. But when you see this, when you see it this way, then I would just do this. 1 over 10 over 21 plus 4 over 5 over 7. Old-fashioned way, right? Now, don't worry about the big numbers. Worry about the fractions. I need to convert. I have 10 27. 7 is a factor of 21, right? By 3, all right? So I would just not even worry about this. 10 over 21, and then we have to multiply times 3 to get this to a 21. So it'd be 15 over 21. Alright? And then, and keep in mind the number that we came up with on the other one was 6 and 4 over 21. Alright? So what I would do is I would bring this down. 1 plus 4 is 5, and then I would work with this. 10 plus 15 would actually be 25 over 21. But again, that's an improper fraction. So to turn this thing into a mixed number, it would be 1 because 21 goes in it this one time, but we have 4 units left over. So 1 and 4 over 21. Now the thing is since we have a number here, this whole number has to be added to this, which would be 6 and 4 over 21. So you see how easy that was compared to everything that we did using the rapid math number. Alright, so again, if I saw something like 2 and 7 over 27 plus 8 and 5 over 9. Again, convert it to the old-fashioned way. 2, 7 over 27 plus 8 and 5 over 9. Old-fashioned way, 9 is a factor of 27. We multiply it by 3 to get to 27. So if we multiply this by 3, multiply this by 3, and again, we're making this fraction match. We're coming up with the lowest common denominator by multiplying this by 3, which gives us 27. We multiply the top of the numerator by 3, it gives us 15. This is going to stay the same because we just need to convert this to 27s. And we've done this by multiplying the numerator and denominator by 3. So we already have the 2 and the 8. That's going to be 10. Alright. And then 7 plus 15 is 22 over 27. And that's our final answer. So you see, when we have the mixed numbers, we have to go to old-fashioned way. We pick the best method. Looking for something interesting. 7 and 4/5 minus 3 and 8/20. Again, I could convert these, and yeah, let's just play with that for a minute. It'd be a nightmare. 5 times 7 is 35, plus 4 is 9. So it'd be 39 over 5 minus 3 times 20 is 60, plus 8, 68. 68 over 20. Okay, now we would have to cross multiply, work out the bottom, and it become a nightmare of numbers. You know, it would be 39 times 20, let's multiply that, minus 5 times 68. And then when we figured out what that was, which would be a nightmare, then we'd have to divide all that by 100. So instead of going through all that, I would just rather keep it the old-fashioned way. 7, 3, 4 over 5, 8 over 20. 5 is a factor of 20. So 20 is going to be the lowest common denominator. In order to get 4/5 turned into 20ths, multiply that by 4. So it'd be 16. We'll have to multiply that by 4 to get 20. We multiply the top to get that to 20ths, 16 20ths. So 7 minus 3 is 5. And 16 minus 8. See how easy that is? So we've selected the better method. (16, 8). Okay, I'm just kind of looking over my work. Final answer. Actually, no, it's not. 8/20. 4, 10, 2/5. And I'm sorry, 7 minus 3 is not 5, it's 4. So our final answer will be 4 2/5. This is why it's always important to just check your work. If I don't catch myself, sometimes even I make mistakes, and so, you know, the more you do it, the better you're going to get. But this was just a simple error. I put a 5 there. It should have been a 4. But I still worked out my math with the fractions. The whole numbers, they do what they do. But the fractions, you have to rearrange them. You have to convert them. 4/5 had to be turned into 20ths. So it's actually 4/5 is equal to 16/20. And then we can do this subtraction. 16 minus 8 gave us 8/20. And then we divided by 2, got 4/10, 2/5, and our final answer, 4 2/5. I love math, you can tell, right? Okay, let's try another one. 9 1/8/20 minus 4 2/5. Again, convert this to the old-fashioned way. It's the easier method. Instead of trying to work them out as improper fractions and getting big giant numbers. This is a 5, not an 8. So don't worry about the 9 and the 4, worry about the fractions. We want to turn 2/5 into a 20th. Since we look at our two denominators, lowest common denominator is 20. 5 is a factor of 20. So how do we turn this into a 20th? We'd have to multiply this by 4 to get 20. Multiply the top by 4. 8/20. Now something very interesting is going to happen here. We don't convert this because we don't need to, but 8/20 minus 8/20, 0. So 9 minus 4 is 5, our final answer. That was pretty cool. And last but not least, 3 1/7 plus 5 and 12/21. Again, convert. Look at the two denominators. The lowest common denominator is 21. So 21, this does not have to be converted. 1/7 has to be converted to 21. So how would we do that? We would multiply by 3 to get 21, so we have to do the same to the top. 7 times 3 is 21, 1 times 3 is 3. We're adding. So 3 plus 5, the whole numbers, we deal with that, which is 8. 3 plus 5, 5 is 8. Don't worry about this because you have your new converted numbers. 3 plus 12 is 15/21. Is that our final answer? No, because this can be broken down further. We can divide this by 3, we can divide this by 3. We get 5/7. So our final answer is 8 5/7. Final answer. So, again, repetition is the key. If you gotta replay this again, work through it, you know, my method is pretty much the fastest. The old-fashioned way works better for the mixed numbers. So we talked about fractions. What is a fraction? It's a part over a whole. We can also look at this as a division sign. Another thing that I'll do another video on, when you have a fraction, 2/4. This is actually a division problem. Okay, it's a division problem. If we look at this, well, this could be broken down to 1/2. Okay, if we reduced it, we divide the top by 2, the bottom by 2. It's 1/2 if we're reducing it. But we can change this to a fraction, and we can change this to a percent. And I'm going to do this in another video, but think about this. When you see 1/2, just think of the 1 falling down, and then we have 2 or 1 divided, going to become a decimal number because 2 goes in as 1 0 times. Alright, and what we would do is we would add a 0 and not even look at this as a 1.0 anymore. We look at this as a 10 now. 0, 1, 0 comes down, 10, 5. So 1/2 is equal to 0.5 in decimal form. That's how you convert a fraction to a decimal. Let's say if we had 3/4. Just think it as 3 falling down and the problem becoming 4 divided by 3. Okay, 4 does not go into 3 anytime, so a 0 would go there, 0 there, 3 would be come down, and we come down there, 0 would come down there, and then the next 37, alright, 28, and we would have a 2 remaining. We add another 0, that will fall down. 20, 4 goes into 25 times. So 3/4 is equal to 0.75. That is a decimal form. In percentages, I'm not going to do that right now, but this equals 50%. This equals 75%. But we'll do that in a different video. So we talked about fractions. We talked about the fractions having a numerator. I'll just put n in the denominator. We talked about our quick our rapid math method. 9 times 1 is 9, plus 3 times 3 is 9, and then we multiply the bottom, we get 27 over 18. That can be reduced. We talked about reduction. We would divide by 3 on the top and the bottom. We get 6 over 9, and then reduce it again, and we would get 2 over 3. We talked about mixed numbers. A mixed number is something like this, 1 and 1/2. We talked about improper fractions. How do we turn this into a improper fraction? We will multiply the denominator times the whole number, and then we would add the numerator. So this would become 3 over 2. And we talked about adding and subtracting mixed numbers. The best way is not the rapid math method, but the old-fashioned way, which is, let's say if we have 1 and 1/2 plus 1 and 1/2, we would just work it out like that. If it was 1 and 1/4 over adding 1 and 1/2, then we would have to find the lowest common denominator between the fraction part of the mixed numbers. 4 is the lowest common denominator, which would be 2/4 over 1/4. And if we're adding, this would be 2 and 3/4. Okay, and then we talked about fractions being looked at as a division problem and how to come up with percentages, and then we also turned a couple of them into percentages. So listen, if you're struggling with fractions and this video gives you a little bit of hope and idea how to work with them, if you need more help, just email me. You don't have to be alone, okay? There's help out there, and you know, just email me or call me. Okay, so again, this has been Math with Kieno. I thank you for watching. Have a great evening.